Now, after defining and sequencing the project activities, it's the time to estimate the duration required to finish the work related to each activity on the project. It's the estimate activity durations process. It's part of the planning process group, and it's the process of estimating the number of work periods, either days or weeks or hours, needed to complete individual activities with estimated resources. So as an outcome of this process, we will have a duration for each project activity. The key benefit of this process is that it provides the amount of time each activity will take to complete. This process is performed throughout the project. It's not performed once. As long as you have activities on your project, you need to estimate the duration of each activity. Now, this process is very similar in the tools and techniques specifically to the estimate activity cost and estimate activity resources. We will apply the project management estimation techniques. Estimate activity durations uses information from the scope of work, required resource type or skill levels, estimated resources quantities, and resource calendars. These are the inputs for this process. I want to understand the scope related for each activity. What are the resources available and the skills and the competencies available for people who will be performing the work related to this activity, the number of resources, and the resource calendars, which show you the availability of resources on the project. Once I have these inputs, I can determine the required duration to finish the work related for each activity. This process requires an estimation of amount of work effort required to complete the activity and the amount of available resources estimated to complete the activity. Now, what are the key factors you should consider or think about while you are estimating the duration of the activities? First of all, we have a law of diminishing returns. When one factor is used to determine the effort required to produce a unit of work is increased while all other factors remain fixed, a point will eventually be reached at which additions of that one factor start to yield smaller increases in output. So look at this chart or this graph. You will have here the point of diminishing returns. What do we mean by this law? Let's assume you are having 3 resources working on a specific activity and they are producing like 10 units per day. Adding another resource might improve the productivity or will improve the productivity. They might deliver 12 units per day. But adding another resource or another resource or another resource, you will reach a point where adding another resource will not increase the productivity. This is the law of diminishing returns. So you need to consider this point. It's not always necessary to add resources to increase the productivity or shorten the duration of the activity. In some situations, you will reach this point and the productivity will not be increased. Number of resources. Adding many resources to an activity may increase duration due to knowledge transfer, learning curve, additional coordination, and other factors involved. So it's not always the solution to shorten the duration of an activity to add resources to this activity. Time will be consumed in the knowledge transfer between the resources, in the learning curve, in the coordination required between the resources. Advances in technology. This may also play an important role in determining duration estimates. For example, an increase in the output of a manufacturing plant may be achieved by procuring the latest technology, which may impact the duration and resource needs. So you need to think about the available technologies that can be used to shorten the duration. Motivation to staff or motivate of staff. The project manager as a leader also needs to be aware of student syndrome. Recently, there is a question in the exam about the student syndrome or the procrastination, when people start to apply themselves only at the last possible moment before the deadline. Also, Parkinson law, that's very important for the exam, where work expands to fill the time available for its completion. So you should expect 2 questions in the exam about the student syndrome and the Parkinson's law. The student syndrome is that the people start to apply themselves at the last possible moment. Like when we were students, this is why it's known as the student syndrome. We were studying for the exam at the last night before the exam. This is the student syndrome. While the Parkinson law, if you give a resource 3 days to finish the work, they will finish the work in 3 days. However, if you give the same resource 4 days, the work will expand to fill the time available and it will take 4 days. 5 days, also it will take 5 days. So you need to consider the student syndrome and the Parkinson's law and the durations estimate of the project activities. Here are the types of estimates that are applicable to the duration, budget, and resources estimates. First of all, the rough order of magnitude. It's the one created at the initiating process group with an accuracy level of -25 to +75, a broad range of estimate, because we are in the initiation phase of the project and we have not enough information. The second one, which is a bit better in terms of accuracy, is the budgetary estimate. Usually it is estimated in the planning phase of the project with an accuracy level of -10% to +25%, and the most detailed one is the definitive estimate with an accuracy level of -5% to +10%, and it is part of the executing process group. So these are the three types of estimates. Now the inputs, tools, techniques, and outputs of the estimate activity durations process are depicted in the figure below. We will need the project management plan. We will need a lot of project documents to understand the scope of the activity, in addition to the enterprise environmental factors and the organizational process assets. Now the tools and techniques that will be used in this process includes the expert judgment and the estimation techniques. These four estimation techniques are very important while estimating durations, while estimating budget, and while estimating the resources needed. Analogous estimating, parametric estimating, 3-point estimating, and bottom-up estimating. We will be using also some of the data analysis techniques like the alternatives analysis and the reserve analysis, decision-making techniques, and we will conduct some meetings. The key outputs of this process are the duration estimates of the project activities, the basis of estimates, the document that shows how we did the estimates, and some updates to the project documents like the activity attributes, the assumption log, and the lessons learned register. Now the data flow diagram of this process shows that we will need inputs from the project management plan, project documents, and the enterprise or the organization. The outputs of this process will be archived in the project documents. So the first input we will need to estimate the activity durations is the project management plan. Mainly, we will need the schedule management plan and the scope baseline. The schedule management plan defines the method used as well as the level of accuracy and other criteria required to estimate the activity durations. How we are going to estimate the activity durations, what are the techniques we will be using, what's the level of accuracy we need to achieve. All this was documented in the schedule management plan. Therefore, it's an important input to this process. Another input is the scope baseline, which includes the work breakdown structure dictionary, which contains technical details that can influence the effort and duration estimates. The work breakdown structure dictionary is the document with all the details of the work breakdown structure components. Now, in order to determine the level of effort and the technicality required to complete the work related with specific activities, we need to have an access to the WBS dictionary. The second input will be the project documents, the activity attributes which describe the predecessor or the successor relationships of the activities, and this will influence the duration. The activity list, which contains all schedule activities required, the ones that we will be determining the duration for as part of this process. The assumption log with all assumptions that might impact the durations estimates. The milestones list. The milestone is the significant event, and the milestone list may have scheduled dates for specific milestones which we need to consider. The lessons learned register in case there are any lessons learned about effective techniques for estimating. Project team assignments. The project is staffed when the appropriate people have been assigned to the team, and the project team assignments, it's a document that is an output of the resources management processes which shows the assignment of each project team member. The resource breakdown structure, which is an output of the plan resources management, we will discuss later. It provides a hierarchical structure of the identified resources by resource category and resource type. And finally, the resource calendar, which influence the duration of scheduled activities due to the availability of specific resources. So if you want to know a specific resource availability in the project, you just need to look at the resource calendar. Project team assignments, RBS, and resource calendars will be discussed further in the resources management knowledge area. Another two project documents are the resource requirements. Estimated activity resource requirements will have an effect on the duration of the activity and the risk register if there are any risks or overall project risk that might influence the duration estimates of the project activities. The third input will be the enterprise environmental factors, and some of these factors that might influence this process includes the duration, estimating databases and other reference data, productivity matrix, published commercial information, location of team members. And the last input will be the organizational process assets, and some of these assets includes the historical duration information from previous similar projects, the project calendars, estimating policies of the organization, what's the scheduling methodology, and an access to the lessons learned repository. All these are organizational process assets you can benefit from while estimating the activity durations. Now, the tools and techniques, starting with the expert judgment, you can consult any experienced resource, either an individual or a group in your organization with experience in estimation techniques. Now, we will have 4 types of estimation techniques. The first one is the analogous estimating, top-down. Quick note here, just keep in mind that the same estimation techniques can be applied to duration, to budget, and to resources. So we will cover them again as part of the cost management knowledge area and resources management knowledge area. Now, analogous estimating, sometimes it is called top-down. It's a technique for estimating the duration or cost of an activity or a project using historical data from a similar activity or project. Analogous estimates uses parameters from a previous similar project, such as duration, budget, size, weight, and complexity as the basis for estimating the same parameter or measure for a future project. So the analogous estimating is mainly based on historical data from similar activities or from similar projects. If I am working with a real estate development firm and we are building hospitality projects, like we are building hotels, and the company executed multiple 5-star hotels earlier, I can use the estimates of the previous hotels if they are similar or the project is similar in size and complexity for my current project estimations. When estimating durations, this technique relies on the actual duration of previous similar projects as the basis for estimating the duration of the current project. And this is what I just mentioned. You just need to look for a similar previous project, check the actual duration of the activities in this project, and try to match them with your current project. Analogous duration estimating is frequently used to estimate project duration when there is a limited amount of detailed information about the project. So analogous estimating is usually used at the beginning of the project, at the very early stages of the project when there is no enough information, and it's more applicable on a project level and not on an activity level. Analogous estimating uses expert judgment and historical information to predict the future. It is usually done at the project level. The level of accuracy of this estimation technique depends on how closely the project or activity you are currently working in matches the past history, the one you are comparing to. For example, if I'm working in a real estate development firm specialized with hospitality projects, I cannot rely on the estimations that were done for a 3-star hotel in order to predict the estimations for a 5-star hotel. So the two projects should be similar. Analogous estimating is usually less costly and less time consuming than the other techniques I will be explaining now, but it is also less accurate. It's most reliable when the previous activities are similar in fact, not only in appearance, in fact. So you need to make sure that you are referring back to a project that is in fact similar to the current project. The second estimation technique, which is more accurate, is the parametric estimating. It's an estimating technique in which an algorithm is used to calculate cost or duration based on historical data and project parameters. So this estimation technique is more based on an algorithm or a formula. It uses a statistical relationship between historical data and other variables to create an estimate for activity parameters such as cost and duration. An example of the parametric estimation algorithms: time per linear meter, time per installation, cost per square meter, produce higher level of accuracy depending on the sophistication and underlying data built into the model. Like if we are working in a construction project of a residential building, and from previous residential buildings projects in your organization or in the industry in general, you know that the cost per square meter is 2,000 US dollars. So 2,000 US dollars per square meter. This is the algorithm of the parametric estimating you can use in order to determine the cost of the current project. The durations can be quantitatively determined by multiplying the quantity of work to be performed by the number of labor hours per unit of work. For example, duration on a design project is estimated by the number of drawings multiplied by the number of labor hours required for each drawing. This is how we calculate the duration. Or on a cable installation project, the meters of cable multiplied by the number of labor hours per meter. If the assigned resource is capable of installing 25 meters of cable per hour, the duration required to install 1,000 meters will be 40 hours. 1,000 meters divided by 25 meters per hour. This is the parametric estimating. It is based on models, it's based on algorithms and formulas. This technique can produce higher levels of accuracy depending on the sophistication and underlying data built into the model, and we mean by the model here the formula. Parametric schedule estimates can be applied to a total project or to segments of a project in conjunction with other estimating methods. So unlike the analogous estimating, which is usually applied at the project level, the parametric can be applied on an activity or on a project level. It's more accurate than the analogous estimating. Now, the most accurate estimation technique is the bottom-up estimating. It's time-consuming, but it is the most accurate one. It's a method of estimating projected duration or cost by aggregating the estimates of the lower-level components of the work breakdown structure. When an activity's duration cannot be estimated with a reasonable degree of confidence, the work within the activity is decomposed into more detail. This is why it's time-consuming. We will start with the bottom of the project and we will start aggregating till we reach the overall duration or budget of the project. The detail durations are estimated, and then these estimates are aggregated into the total quantity for each of the activities' durations. Activities may or may not have dependencies between them that can affect the application and use of resources. If there are dependencies, this pattern of resource usage is reflected and documented in the estimated requirements of the activity. So in this technique, we will decompose the current activities into a more level of detail, and we will start determining the duration of those sub-activities, and then we will aggregate to find out the total quantity of duration for each activity. The last model or the last estimation technique is the 3-point estimating. The accuracy of a single point duration estimates can be improved by considering estimation of uncertainty and risk. Using 3 points estimates will help us define an approximate range for an activity's duration. So in this estimation technique, we will not rely on a single point to estimate. We will rely on 3 points. The first one is the most likely estimate based on the duration of the activity, given the resources likely to be assigned, productivity, realistic expectations, and dependencies. So this is the most likely estimate for an activity to be completed. Optimistic estimate based on the analysis of the best case scenario of the activity. The pessimistic is based on the analysis of the worst case scenario of the activity. So for each activity, the estimator will provide us with 3 points: the most likely, the optimistic, and the pessimistic. 3-point estimates can be used to calculate a risk-based expected duration estimate for an activity by taking either a simple or weighted average. So we have 2 formulas in order to find out the 3-point estimate for an activity. The first one is known as the simple average or the triangle distribution. It gives equal weight to each of the 3-point estimates when calculating the expected activity duration or cost. The formula to find out the triangle distribution or the simple average is the pessimistic estimate plus the most likely plus the optimistic divided by 3. The second type of the 3-point estimation technique is the beta distribution or the weighted average. it gives a stronger consideration to the most likely estimate. It is known as the PERT estimate, and you should expect at least 2 questions in the exam about the PERT estimate. The expected activity duration using the PERT formula is P plus 4M plus O divided by 6. So a bigger consideration was given to the most likely estimate. This method leveraged the benefits of risk management in reducing the uncertainty of estimates. In a scenario of that you don't have enough experience or historical information, it's enough to use the triangle distribution or the simple average. Now, another formula which is important and related to the PERT formula, it's the activity standard deviation. How to determine the range of the estimate. Like sometimes you hear that this activity might take from 12 to 14 days. So how to determine this plus minus range? It is the possible range of estimate. This is the standard deviation. For example, if an activity takes 40 hours to complete with a standard deviation of plus minus 4 is expected to take between 36 and 44 hours. This is the range of estimate for this activity. It's 40 plus minus 4, so it is from 40 minus 4 to 40 plus 4. The greater the range created by the standard deviation calculation, the greater is the uncertainty and the risk associated with this activity. This is a very important sentence for the exam. The greater the range of the estimate, the greater is the uncertainty and the risk. Now, how to find out the standard deviation? It's P minus O divided by 6. It's the pessimistic estimate minus the optimistic estimate divided by 6. And the range of estimate for this activity is the expected activity duration plus minus the standard deviation. That means that the range of the estimate starts with the expected activity duration minus the standard deviation and ends with the expected activity duration plus the standard deviation. Let's see an example on the PERT formula. An activity with optimistic duration estimate of 20 days and pessimistic estimate of 32 days. Knowing that the most likely estimate is 24 days, what is the range of estimate? So you were given the optimistic estimate, the pessimistic, and the most likely estimate. In order to find out the range of the estimate, we need to determine the expected activity duration and then determine the standard deviation. Now, applying the PERT formula, expected activity duration equals P plus 4M plus O divided by 6. P is 32, the most likely is 24, and the optimistic is 20 days divided by 6. It's 24.66 days. Applying the standard deviation formula, it's P minus O divided by 6, so it's 32 minus 20 divided by 6, 2 days. Then the range of estimate is 24.66 plus minus 2 days. Now, these were the 4 estimation techniques. Additional techniques we will be using while estimating the activity durations are the data analysis techniques, starting with the alternative analysis. When activity estimates are not acceptable within the given project constraints, alternative analysis is used to look more closely on the variables that impact the estimate, used to compare various levels of resources, capability or skills, schedule compression techniques, and make or buy decisions. So we can use alternative analysis to assess the options or the alternatives available when it comes to resources assigned to each activity. We have also the reserve analysis used to determine the amount of contingency and management reserves needed for the project. Now, contingency reserves and management reserves will be discussed further in detail as part of the risk management knowledge area. However, the contingency and management reserves are amounts of time or budget set aside to deal with the project risks. Duration estimate may include reserves, sometimes referred to as scheduled reserves, to account for the schedule, uncertainty, and the risk. Contingency reserves are the estimated duration within the schedule baseline, which is allocated for identified risks that are accepted. So, as part of the risk management efforts, we will identify the project risks. Okay? Now, for some risks which we cannot mitigate or avoid, we need to set aside an amount either of budget or duration to deal with those risks once they occur. This is known as the contingency reserves. So they are made to deal with the known unknowns. Unknowns are risks. Known because we identified those risks. which may be estimated to account for this unknown amount of free work. As more precise information about the project becomes available, the contingency reserve may be used, reduced, or eliminated. Now, management reserves have the same concept. They are a specified amount of the project budget or schedule withheld for management control purposes, and they are reserved for unforeseen work that is within the scope of the project. Some risks cannot be identified earlier, they will just occur. So how to deal with those risks which we did not identify earlier? By using the management reserves. So management reserves are made to deal with the unknown unknowns, risks that we are not aware of. Decision-making techniques can be used in this process, like the voting, and one variation of the voting method that is often used in the Agile-based projects is known as the Fist of 5, or also called Fist to 5. In this technique, in this voting technique, the project manager asks the team to show their level of support for a decision by holding up a closed fist, indicating no support. So if a project team member holded up a closed fist, it means he is not or she is not aligned or supporting the current decision. Up to 5 fingers of the fist, this means that the team member is giving the full support to this decision the team is voting for. This is why it's known as the Fist of 5. If a team member holds up fewer than 3 fingers, the team member is given the opportunity to discuss any objections with the team. The project manager continues the Fist of 5 process until the team achieves consensus or agrees to move on the next decision, and this technique can be used to agree on some of the activities durations where there are conflicts or the team is not aligned on the proposed duration. The last tool of this process will be the meetings. If Agile approach is used, the team need to conduct sprint or iteration planning. A sprint or iteration planning is a meeting we conduct before the start of each iteration to discuss the items in the prioritized backlog. The backlog is the document or the artifact where all the user stories, all the project requirements are being documented, and decide which items the team will commit to work on the upcoming iteration. So we can use the iteration planning meeting in an Agile development approach in order to plan and determine the duration required for each activity. Now, the key outputs of this process are the duration estimates. This is the key output actually. Quantitative assessment of the likely number of time periods that are required to complete an activity. We say time periods because sometimes it's calculated in hours, sometimes in days, in weeks, in months, etc. So it's just time periods. Duration estimates may include some indication of the range of possible results. For example, a range of 2 weeks plus minus 2 days indicates that the activity will take at least 8 days and not more than 12 days, assuming a 5 work week. Or a 15% probability of exceeding 3 weeks indicates a high probability, 85%, that the activity will take 3 weeks or less. Estimates can be provided in such formats. Another project document is the basis of estimates. The amount and type of additional details supporting the duration estimate vary by application area. Regardless of the level of detail, the supporting documentation should provide a clear and complete understanding of how the duration estimate was derived. So how the duration estimates were derived, what are the techniques you used, any attributes for those estimates, all this should be documented in the basis of estimates document. The third output is updates to some of the project documents like the activity attributes. Duration estimates estimated are documented in the activity attributes. Any assumptions made for estimation purposes will be added to the assumption log. Any lessons learned about the estimation techniques and the effective ones can be added to the lessons learned register.